so as I was saying, farmers are really hard to recruit, especially because they have very high opportunity cost of participating, so expensive to recruit. And also there is the problem of low response rates that has been observed in the studies by Weigel et al. And Messer et al. So we look particularly at the fundamental preference of the time preference, or by looking at the individual discount rates of farmers and university students with the following research questions in mind. So first we ask, can students be good stand-ins for farmers? So this is that question of external validity. And secondly, how are the estimates across students and farmers affected by the scale of incentives, that is what we're paying them, front-end delays, that is the time period that between me participating today and the time that I get the sooner payment, and I'll talk about that in detail, and the temporal horizon, which is the difference between the sooner payment and the later payment. And why are we interested in looking at time preferences for students and farmers? It's because it has far-reaching conclusions, right? It determines a lot of farming behavior, such as adoption of new technologies, provision of environmental services, and participating in conservation programs as well. So examining this particular time discounting preference would be very important. So what has been observed in the field? What has been observed? Has there been any studies done between farmers and students? Well, generally, students make more impatient choices in discounting tasks because they are more liquidity constrained. And secondly, there has been a study that is still a working paper, and they are the only study so far that has done a comparison between farmers and students, but these are not any students, they're agricultural students. So they've compared farmers and students, agricultural students' mind, and they have found that the students are actually less impatient than farmers, and this is a study that has been done in Germany. So what do we do in our experiment? We implement a discrete time budget mechanism, and this was first introduced by Andrioni, Kuhn, and Springer in 2015, and we have 416 student participants and 393 farmers across 26 states. So it's pretty, it's covering a lot of region here. And the most important part about this is that we have the same number of, at the initial sample size, has the same number of students and the same number of farmers from the same state. So there is that uniformity maintained where you cannot say that, oh, the student from this state can behave differently from the farmer in another state. We control for that by having students and farmers in the same state. And then what they do is they participate in this discrete time budget elicitation, and they can choose between 6 dated dollar bundles with sooner and later payoffs. And the experiment duration was 30 minutes or a little bit more. And they actually, these are high stake experiments because the average earnings have been $100 approximately. So what are the treatments we implement? We vary the scale of incentives. So they either can choose between $30. So the different parameters here is $30 now or later, $500 now or later, or $1,500 now or later, and that's varied. And I'll show you what the interface also looks like to get you some clarity there. And then the front end delay, as I was talking about, is the time between participating and getting the sooner payment. And this is varied for 1, 26, 52, and 78 weeks. So why do we have different types of why do we have this front end delay to begin with? Because it minimizes the additional risk of transaction costs in the later option. Because if you show up and you are told that you will get this payment today, then you are more likely to do that because you just don't want to have to wait ever at all. So by adding that front end delay, you are minimizing the possibility of me choosing the sooner payment just because I couldn't be bothered to wait and incur that transaction cost. And then finally, we also vary the temporal horizon, which is the time between the sooner and later payments. And that's 26, 52, or 104 weeks. So this is what the experimental interface looks like. And in this particular interface, as I was saying, the sooner payment is $1,500 or $0, right? And so the incentive here is $1,500. And the front end delay is 52 weeks because the payment is in 12 months. And the horizon is 26 weeks because the difference between the sooner and later payments is 6 months in this case. And so, as I was saying, these incentives vary. So there are some interfaces where the sooner payment would be $30 and some interfaces where the sooner payment would be $500. And accordingly, the front end delay and horizon is also varied. So now I will present some preliminary findings from this study. And this is the big punchline that we find that students and farmers actually do not vary very much when it comes to discounting and curvature estimates. So this graph shows you the individual discount rate between students and farmers, and the median discounting rate, as you can see, is very close to each other, and we calculated at 0.08. And the next graph is the curvature estimate, which we find is again very similar between the students and farmers. So in general, we find that students and farmers are actually students can be good stand-ins for farmers. So next we look at the smoothing, like whether students smooth consumption more than farmers. So in the y-axis, we have the mean earlier tokens, which is the average bit of the sooner consumption divided by the sooner consumption and the later consumption. And we find that in general, students, which is the red line, is on top of the farmers. So visually, we can say that students tend to smooth consumption more than farmers. But let's look more closely at the parameters of the experiment to see if we find any characteristics in how students and farmers behave, whether they are similar to each other or different to each other when we vary the parameters of the experiment. And what we find here is that the scale of incentives definitely matter. As you can see very clearly, when the incentive is small at $30, the students' behavior is different from that of the farmers. And when we start increasing the scale of incentives to $500 or even $1,500, the scale of students and farmers start behaving like they start to come very close to each other, as opposed to when it was a small incentive of $30. So next, we look at the front end delays data, and it is a little bit noisy here, and I don't want to make any conclusions without testing for significance. But what is very clear from the 78-week front end delays that this graph is like the students or farmers are almost the same here. So students can be good stand-ins for farmers when the front end delay is longer. Next, we look at the time horizon, where we find that it matters, right? Well, in longer time horizons, students do start behaving like farmers. And so as I mentioned, these are preliminary findings and there's quite a bit of work to be done. So I will just conclude by saying that yes, in general, students can be good stand-ins for farmers because their median curvature and individual discount estimates are the same. And it does matter what the incentives are and the front end delay. The longer it is, and the larger the incentive, the better it is for they start behaving more like each other. So these things need to be kept in mind when we are designing an experiment for students and farmers. First, and kind of just seeing when we can actually use students and we can't, right? So thank you very much, and I'm happy to answer questions.
For my presentation, a little bit more about the makeup of the students. So the Germany study was specifically agricultural students, like correct? And you're just saying migrant students, were they filtered by like state major and what was the major and what type of farmers? Do I feel like there could be some?
Right. Yeah, so for the Zoom participants, I just want to repeat this question and my co-authors can jump in as well because I'm not 100% sure on what the majors were. But the question is that, you know, in the Germany study, they are particularly using agriculture students. So for our study, were we mindful or cognizant of what was the what disciplines the students came from, and how did we go about recruiting the students? This is a question from Kelly Davidson. Yeah.
Yeah. So farmers were farm market ID recruited. So broadly, whatever's in that database was what was there. And then we went out to the different states and contacted some of you that, hey, you just recruit like you normally would recruit an undergraduate school. So, so if that was at Purdue, that's how, Jim was going to go do his, or, Samantha was going to do it in Nebraska. They weren't ag students necessarily. I would assume most of them did. I think you tried to.
So that's the general.
Right, that's right.
Right. Yeah, I think.
Yeah. Why do you think this taps specific for parents and farmers? Is it, would you want to do also a measure for other students if they line up similar as well for the generalization?
Yeah, so this question is, why did we use particularly the individual discount rates? Why are we looking at time preferences only when we are comparing students and farmers? Why, or, making the conclusion that students are good stand-ins for farmers by just examining one aspect of the of just time preference? And yeah, that's a very valid question. So this is one of the fundamental preferences that determine how we make choices. And as I was saying, the context here is really looking at farmer behavior with respect to conservation practices. And that's where time preferences really matter in terms of technology adoption and conservation enrollment. So we thought that this was a good way, a good start off point for sure, but for sure, and there have been many studies that are doing these comparisons, not with farmers, but they look at other types of behavior like trust and competitiveness and all of that. So yeah, this was just a starting off point. And there's another section that looks at risk behavior as well, but this is preliminary work where we've just started off with discounting behavior. Yeah. Any other questions? Yeah.
Was it a non-incentivized tax?
No, it was incentivized.
It wasn't.
Yes, yes. And the average earnings were $100. Yeah. And if nobody else has questions from the audience.
You have 2 questions in the chat box.
Okay. Okay, yeah, we have questions in the chat. One is, could you speculate why students are more like farmers? And this is from Pallavi, at higher incentives and longer time frames. Farmers are much more experienced than students, and we know experience matters in decision making. Are you also implying that at higher incentives and longer time frames, experience matters less? That's a very interesting conclusion, or you know, a very interesting conjecture to have about why they start behaving like each other in longer time frames and incentives. And I haven't, to be honest, I haven't thought of it that way. But this is definitely something that I will explore and make a note of. So thank you very much for that comment. Any other questions? Okay, so then I will hand the mic over to Kent for his next presentation. And I can start. Let me just share the screen.
All right, can people online see this in the presentation? And if I move it,
Yes,
it
Kent.
goes. All right, thanks, Paul. Well,
We can see we don't see the presenter mode. We just see like your slides on the left. I don't know if you've gone full screen.
tell me again, is it? Yes, please.
There, we can see the full screen now.
Great. Thanks, Paul. Thanks, Leah, for saving me here. Always appreciated. This is a talk that I'm super excited to share with you all. And thanks for being here on a late afternoon on a Tuesday, the conference. So this is joint work with Paul Ferraro at Hopkins and work with Colin Weigel, who was at Hopkins, but now at the California Air Resources Board. And we're really going to be talking about, what happens when you start, doing multiple interventions at one time, right? If we do multiple nudges, do we get a good long push, or does someone get more resistant or something like that? We can imagine lots of different scenarios. So we'll test it and see what we can get in terms of adding to the evidence base. The research was funded by the Economic Research Service and NIFA, and as part of the CBEAR project. And so, one of the things that you've been seeing throughout this session is, kind of looking at really diving down into the farmer versus student perspective, right? And this is gonna be like the producer versus consumer perspective, because if we think about all the nudge, not all the nudge research, but almost all the nudge research on, how well we eat, or how much we eat, or how much money we save in retirement, or all this, it's all these consumers doing things, and it's almost always individuals doing things. And we've been very interested in saying, well, what about profit maximizers, not just utility maximizers? What's happening in those contexts? And let's get away from just private goods like my food or my retirement, but to look at things that might be private and public goods, such as agro-environmental contexts. Because we don't know how these types of nudge interventions work in those ways, or at least the literature is a lot smaller. And so, we've been continuing to do this research out there. and begin to look at things also in competitive environments. We've known that has kind of wiped out nudges in the past. Perhaps they do some more in other contexts. And a competitive situation is an auction, right? And as we heard in the last session, there's a lot of conservation auctions out there. Even the largest conservation program in the world, the Conservation Reserve Program, is a type of auction. And so billions of dollars are being spent through this situation. Farmers are making decisions, perhaps at the household level, so similar to consumers, but obviously there's a profit maximizing element underlying it all. So, what are we going to do? What are we going to do in this auction? We're going to look at two main treatments. One is going to be anchoring, kind of a classic behavioral science insight that if you anchor people high, they tend to bid high. They think of high numbers. If you anchor people low to start with, they go with low numbers. Could this matter in an economic context? And usually the answer in lab is yes. You can see these really strong effects, maybe unbelievably large at points. And often these are driven by small samples and low powered studies. And of course, we've got the classic concern for publication bias. If you've got this really large effect of this nudge, it's going to perhaps be something more desirable from the publication literature. And then I'm going to do second treatment. And the second one is just going to be kind of a stewardship, reminding farmers that when they do agro-environmental practices, that it has these external benefits to their neighbors and to the local environment. So two kind of simple, classic nudges, interventions that are there. And then what we're going to try to look at a bit is in what happens to the stacking of these treatments. Are we going to find something that's really good? And partly when you start looking at field experiments and you're doing randomized controlled trials, doing more than a couple interventions becomes quite expensive. If you start now looking at interactions, that becomes more expensive. So most of them have not been doing situations where you can look at whether stacking is going to make a difference. And please correct me when I'm wrong here, but we can't find them in a producer context. So send me a note, say, Kent, you're wrong again, and you'll get cited in our paper, right? So there's a good little incentive there. So again, something we haven't seen. So let's talk about stacking a little bit. I'll go back to some of my earlier research that was kind of about stacking in the voluntary contribution game. We start out with that, oh, here's a 50% to 0% classic game that Andreoni and Isaac and Walker all worked on. And then say, well, we could start doing things like we could have a change in the default of giving and see a little bit of effort, but then, hey, we could stack that and add some cheap talk on it. And hey, look at contributions grow and they get a little bit better. And then we could do democratic voting and we could push it out and look at, if we start stacking giving, defaults and cheap talk and democratic voting, maybe we can get these really great results. That's a kind of a dream world scenario. Glad that was my dissertation paper, because I don't think we've seen these type of results too often in the literature, right? And so if we think of all the intervention stackings that are out there, one is this kind of ideal thing that, hey, you add these more and more together and you get this like super stacking event, right? And everything comes together and you're getting something bigger than the sum of the parts. So I made up a little example here in which we could say, if anchoring increases people by 3%, percentage points and stewardship goes by 6%, then a super stacking event is something that goes better than 9, right? Of course, we can think of option B. It's just linear. You get 6 plus 3 is going to get us around 9. That's kind of good. Maybe kind of can't get quite up to that whole 9. You don't get it linear. Maybe it's it's better than the best, but you don't quite get to 9. So that would be option C. Maybe we're really just kind of getting improvements over the worst case, option D. Maybe we're actually starting to see that they compete with each other. Maybe you'd end up getting something less than the worst situation, or maybe even none at all. So there's lots of different things are out there. Obviously, we'd like to think that we're pushing things in this kind of big stacking event, or at least it's linear. But let's look at the evidence and see what we can find in this case. And let me draw upon a field experiment framework that we've been running for a little while. It's called AgVise, standing for Agricultural Values, Innovation, and Stewardship Enhancement. And it's an auction setting where we bring out with farmers. And in this case, we were running it with farmers in the Southeast United States who are facing problems with feral hogs. And if you're not familiar with the feral hog problem, it's an invasive species, causes over $1.5 billion in crop damages. So there's a lot of private costs that are incurred by farmers from these feral hogs. They breed quickly. They're difficult to catch. You can shoot them, but they can often still be, you can't shoot them fast enough. They can still breed faster. They can become more scared. And so it's kind of a weakest link public good problem. And there's also environmental challenges that are there. You can see in the bottom left here, here's an example of a farmer that participated in this auction. And we ran these in person in a number of different settings, primarily at the Sunbelt Ag Expo down in Moultrie, Georgia, also the Amarillo Farm and Ranch Show in Texas. And we allowed people to do this online as well, where we'd send them a code and they could do it at home. We also thought it was important that if they were at an expo and they made a big decision, these are $4,000 decisions potentially, so these are non-trivial, that they could go home and change their mind. If their spouse thought they just made a really stupid mistake, they could go back and adjust it. We felt that was something that was important. It wasn't trying to force someone in, because it was a 20 to 30 minute experiment. We paid them $50 to participate, but it's a bigger choice, and we wanted people to be very deliberate about that. And again, there's some screening, it had to be over 25, had to have $1,000 or more in farm revenue, and they farmed the south east of the United States. This was something that we did not try to verify. We just took their word for it, that they qualified. And what were they buying or considering? They were considering a Jaeger Pro trap, right? And so that's a picture on the left of the trap, in which you can use your smartphone technology and watch it at night with night vision to see how many of the hogs are in this trap. You bait it, of course. And so you would try to get more and more of the whole sounder there. And then at one point you can just press your button on your phone and the trap collapses, right? And so you can get more of the entire group. And then you can do whatever you want with those. So we assume they all went to some petting farm or something like that, or maybe they ended up being eaten or disposed of in whatever way. We were not trying to judge people on what they were going to do with the trap. We were just getting them a trap, and they could do that what they wanted to with it. So we provided a little video. What's this trap? How does it work? Kind of cool technology. So we gave them that information. Here's our stewardship message. I know it's too small, sorry about that, but the whole point is it's got problems with the environment, because these hogs often do live in the streams or near the streams. They damage streams, they poop in the streams, and the fact that they, if you don't control your hogs and your property, they're going to start impacting your neighbor's property, right? So there's this kind of a public good message there. We'd explain to people how this cost share program worked, give them some examples to work through. Again, we tried to use videos as much as possible so people were comfortable with it, but then gave them the language as well. And then ultimately worked up this key question, right? Would they want to make a bid? Some people don't want to. Maybe about half didn't even want to submit a bid at all. And maybe they preferred to hunt them. They thought it wasn't such a big deal. They didn't want to buy the trap. They would get the $50, go home. They weren't very valuable for our data, other than with the survey stuff they gave us. But what we wanted to do is who bid on the trap, and that's what we started caring about. And as soon as you said yes, I've got that. And I should say the stewardship message was given to half of them, right? It would be randomized. And then likewise, we're going to randomize the anchoring, and half the group is going to get something like this, where their anchor is set at 0%, and that means that they would pay none of the trap. And we'd pay the entire $4,000 cost, but all they'd have to do is to click on that slider and move it up, and it would immediately adjust their price. They could see it. They could even use this negative or positive sign to adjust it. So very easy, automatic response to see what the payment was. The other group would get the same type of slider, but it would be started off at 100%, and they'd have to move it down. So both of them would have to do it. You can imagine there'd be some value like this. Someone comes in and says, it's my current bid 71%, and you can again see how it adjusts there. Now, we did tell them that we would be accepting that auction worked in the way that the people who offered the highest amounts of percentages to pay for the traps were more likely to win. And so They were recognizing it was a competitive environment, and it was open for a period of time, just like many USDA programs, enrollment programs have an open period of time. So we collected a whole bunch of bids, and then after several weeks, we determined who the winners were and implement those traps. We did want to have people confirm their bids so that we weren't making mistakes, and so if they said there was 71%, they could go back at any point. And then again, we told them, we gave them little codes at the way back so they could even go back and adjust it later if they decided in the moment, because it was an open enrollment period. We had over 1,000 people there. About half of them submitted bids. A little bit younger than the average farmers, right? 46 years, but 20 years in ag on average. About 550 acres were farmed, mostly from Georgia. Again, that's where our heaviest recruitment was from, but again, a lot from the Southeast. And 86% reported having damage to, because of hogs. So they're pretty, familiar with this problem. And about a quarter of them had participated in the CRP. The average bid we got was 20%. So they were willing to pay for a $4,000 trap. They were willing to pay about $800. Seems pretty reasonable. Let's jump into the results. Okay, first result is what we all know. It's hard to recruit farmers, right? So it's really hard to, even when you do all this work at the fairs and online and others, it's just hard. So you can see the Weigel et al. Paper in AEPP a couple of years ago about how some of our online recruitment got 0% responses and things like that. So depressing numbers there. In person was certainly better. Another thought that we thought it was important to talk about is, do farmers like auctions, right? I mean, we talk a lot about, we can use these conservation auctions or not. And we don't have a lot of evidence on whether they like it or not. Well, on average, if we just think about all the participants, they were pretty much in the middle on a 1 to 9 scale. The mode certainly is at 5. But if we think about the bidders who went in, they did like it, right? They were skewed on the high side, whereas favorable. I think that's important to know, that we're not pushing people, that probably people who don't like it won't bid. Probably not too surprising. But let's look at the results. And again, I'll keep things simple by simple pictures to illustrate it, because I think it tells us what we're going to want to find out. You can ultimately read the paper later to show all the ways we robustness checked it. But let's just look at the picture to start right with. In our control, on average, 18% was the average bid, but when we gave them these treatments, the stewardship treatment pushed them up to about 24%, right? Anchoring was 24% again, right? So we all push them up, but when we do both, we see it being pretty similar to either one of these two treatments, right? So it drops slightly, but insignificantly down again to 23.6%. So I think this is interesting, right? One is we do find, if we just go back to the original motivation, could something like a nudge on anchoring work? Well, yes, it can, right? And we can see an increase in percentages there. Likewise, a stewardship message in this case also was valuable. Consumers were, or producers were, motivated by the impacts of these traps on how it could impact others. In fact, we had some really interesting behavior. It'd be cool if we could see it more. We know that some neighbors ended up working together, saying, "Hey, I'll use the trap on my land for a little while, then you can use it later, because of course it's a durable good and it can be passed along." So people were building upon it, some clustering that was there. And so we can see, what does that mean? What does this lead us to? I'll go back to this kind of original idea, right? Where do we see this great accumulation of these types of interventions? The answer is no, right? We don't even see a linear piece that's happening. But so we can rule out A and B. We can also rule out with our sample that it's really decreasing, right? If you add these things, is it causing any great problem? Not in this context. So it's not like it's going backwards, but we aren't seeing the stacking that we like. And we can't really distinguish, given the sample size, between whether or not it's actually going below or slightly above. We need more sample to determine that. So we could just leave those as kind of open. I want to wrap up and give some final thoughts here, the policy impacts, right? So, why would someone care about this? Why would a program doing it? Well, you can just use money more cost effectively, right? If you can use these type of interventions, whether it's a high anchor or a stewardship, then you can get more traps out there for the same amount of money. Or if you have a certain number of traps, you can get them out there for less money. And so here's some, example of the number of traps. If you had high anchors are going to help bring people there. And again, you think about who wins the bids, right? It's the people who put in high bids, right? So those are the people you're going to sell it to in an auction. So again, short, simple, and happy to take some questions here. Yeah, Tongzi.
So, yes, I was just wondering, how did you come in that graph with the anchor? So the anchor is continuous.
No, the anchor in this case was all or nothing. Like you were at 100 or 0.
Oh, I see.
Yep. Yeah.
I was curious, how would you explain the message?
Where is it coming from, right? Well, I'm open to explanations. I don't know if we have one, right? We're probably just, that's a challenge with so much of this type of work, right? Is what's the mechanism that is driving the behavior that's lying there, and then especially when you start thinking of intervention that are being stacked together, what is it that's weighing it out? Is it really the anchoring? Is it the stewardship, or did both of them become half as valuable and they added up to this? I don't have a good answer at this moment. I think it's probably something as we write it up, we need to think more about. I'm sure we'll be asked by reviewers and editors to give some at least ideas on that. Yeah. Oh, no, we would have a certain pot of money. I think we usually had about $60,000 to pay out. And so we'd be implementing about 20 traps usually for the auctions. So it wasn't just one, and they were aware of the pot of broad funding. That wasn't just going to be one person that walked away with it, that there was going to be multiple winners.
Collaboration.
Yeah. Yeah, I mean, you're certainly right that as more and more people participate, the competition of it is going to be there. I believe that we did try to provide some estimate to try to keep that constant. We tried to provide estimates of based on previous, things we thought there was going to be about 300 bids that were in. So they would give them some estimate that was being held constant, whether it was right or not. At least, we would say, well, we provided everyone that same information to try to do it. Again, we ran a couple different settings, right? So there were a couple different auctions. So yeah, I mean, the question is, would the competitiveness somehow impact these other interactions, right? Do we have a third intervention here, that we haven't really controlled for, which is more and more competition. And that's in my senses in this study, we're okay with that. All right, we have a question here from Pallavi. How do we know the effect we see is from priming / stewardship treatment and not simply experiment or demand effect? Well, I guess I'm saying that because the control, right? We would have the experiment. We would, that would be the control still had the same experiment going on. So we would think that the stewardship, I mean, would have captured that as well. And so that would be the only change there. So that's my answer to that. So yeah, could there be experimental effect? Of course, right? They might think that we were really great people to buy traps from, but that should be held constant throughout the experiment. Yeah, Travis.
One small question. So do you control, you mentioned the story about people that know neighbors and maybe, so do you control for whether they know, whether they have any neighbors who also participated in the experiment? Or maybe you don't even know that. And it's just an anecdote.
It's an anecdote that you go back and you go, gosh, I wish I knew, right? I mean, so how we knew about it is they withdrew from the auction, right? So two different neighbors ended up both submitting bids, and then they talked about it later at the Moultrie Fair and say, hey, I bid that was great. And like, hold on, why are we bidding twice? Why don't we go back in and take one out and bid up a little bit higher, win the trap, and save money versus buying two traps? And so we know that group did it. Did others do it? Well, probably. It seems like a reasonable thing that people would do, but we have no idea how widespread it was. I'm thinking the only thing that saves us is that we allowed them to go back and adjust it. Otherwise, I think that really could have affected our data. And so the fact that maybe other people just adjusted lower or something like that. But that would be, that's how we found out about it, but nothing systematic. And I think it would still be difficult to do, even if we've done it in advance and known that was a problem. Like, how would you, because some people are going to enter in at different times. And so you have to almost go back at the end of the time and see, some type of geolocation and evaluate on who the bids were and how they behaved. But I think about agglomeration bonuses. I know Samanti was talking in her last session about that. Again, this has an opportunity to say, hey, if you get these traps in certain areas, this could really benefit from coordination on this stuff. All right. Well, thanks. This was fun.
Paul, you're up next. Yeah, let me just.
Can everybody hear me okay?
1 second, Paul. Let me just close all the presentations. Yep.
Can you see my slides?
Yeah, we can see your slides.
Yeah, looks good.
Yeah. Perfect. So first of all, let me apologize for not being in person. I am literally moving tomorrow to Texas from the East Coast, and I thought that I was going to be able to cram everything in, and last minute that didn't work out. So that's why I'm presenting virtually, but I would have loved to be there in person and meet you all in person and deliver this presentation in person. So without further ado, let me begin. So this presentation is called a certainty of, well, the paper is called the certainty effect for preference reversals under risk experiment in theory. This is joint work with Paul Ferraro. But before I tell you what this work is about, let me give you a little bit of motivation, like general motivation. So there's essentially two schools of thought with respect to the measurement of risk preferences. This is kind of a caricature, but it's kind of to give you a bird's eye view of the field. So you could think of the first school, the one I'm going to call the psychologists. So psychologists have long argued that risk preferences, at least the way we economists think about them, don't really exist. They're entirely constructed by context, and there's something that essentially is determined by the type of questions that you ask, and it's not something that individuals carry around. On the other side of the aisle, I would say you have the economists in the room, or the second school of thought, that think of risk preferences as being a stable trait, right? Many of us in the room think about people as carrying maybe a gamma or a parameter that determines their willingness to take on risks. And the reason that economists are interested in measuring this parameter is because we believe that these things called risk preferences determine production, investments, and planting decisions, just to give a few examples from the field. So what I'm going to show you is an experiment that calls into question basically both schools of thought, but the paper itself kind of has a reconciliation between these schools of thought, where I rescue kind of the leading ideas from both schools, mash them together, and come up with an explanation for why we're observing the type of behavior that we're observing. So let me jump directly into the presentation. What's this? Okay, sorry, my slides weren't advancing. So why should we care about measuring risk preferences in the first place? So as agricultural economists, we have a long tradition of measuring risk attitudes. In many ways, we were pioneers in this field, going back to Binswanger in the 80s, using lotteries in India to measure risk preferences. Now, there's also explanations in the literature that argue that perhaps the reason that we observe underinsurance and perhaps also over-fertilization has to do with some behavioral biases. So we would like to understand whether we can capture people's risk aversion or willingness to take on risks using some either not expected utility models, expected utility, or even just the profit maximization model. So as I said before, the reason that we're overall interested in these things is we believe that risk preferences determine to a large extent technology adoption, crop diversification. And if I have time at the end, I'll talk about how we also believe that we can leverage people's risk preferences and provide them lottery incentives. Okay, so that's kind of the general motivation for why we're interested in eliciting or measuring risk preferences. Now, let me give you a glimpse of where this field is at. So the canonical model, and this shouldn't surprise anybody in the room, that's expected utility. And the main reason that we've deviated away from expected utility, at least since the 70s, or some people might claim even since the 50s, has to do with two primary anomalies or paradigms that the expected utility can't really explain. And the first is the local or changing nature of risk attitudes. So the canonical example of this is the fact that people buy both lottery tickets and insurance. And if you buy lottery tickets, that means that you are risk seeking. And if you are purchasing insurance, that means that you're risk averse. So there seems to be some sort of relationship between your willingness to take on risks and the chance that you'll have a good outcome. So this, the canonical model of expected utility struggles to accommodate this. The second type of anomaly is something called preference reversals, which was first identified by Slopik and Lichtenstein. And this is the idea that people might behave differently when pricing lotteries than when comparing them. So that's what I mean by different contexts might influence how people choose the amount of risk that they want to take on. So this is not just me trying to convince you as the audience that these anomalies or these paradigms are important. Here I have two instances of leading models in this field. The first is third generation prospect theory. So first and second generation prospect theory dealt with the first issue, that is the local or changing nature of risk attitudes. And essentially, the reason that these authors came up with a third version of prospect theory was just so that they could accommodate preference reversals. So you could think of these two anomalies as kind of being a litmus test for any new theory that is trying to replace expected utility. You either have to say how you address the local or changing nature of risk attitudes, or how you address preference reversals, and preferably how you do both. And a prime example of this is salience theory by Bordello, Janelli, and Schleifer, which came out in the QJE, which essentially the two litmus tests that they proposed in their paper and that they show is that it can accommodate these two type of effects. Okay. So let me be a little bit more precise as to one of like the core ways in which we think about this risk or changing nature of risk attitudes. So what I have here is from 1992 Cumulative Prospect Theory by Kahneman and Tversky. And what I have here is on the x-axis, I have a chance of a positive outcome. Let's say it's $10, otherwise 0. So this is with what chance you're getting $10. And on the y-axis, I have the median subject's willingness to pay for this lottery divided by the total outcome. So let me center your attention on this point here in the middle, right? So this point is a 50% chance of $10. And you can see that the median subject is willing to pay around 40% of the maximum outcome. So this would be 40% of 10 or $4. So the other thing that I want to draw attention to here is because you're paying $4 for a lottery that has a 50% chance of $10 or an expected value of $5, the willingness to pay is below the expected value. So this would be consistent with risk aversion. So any point on the 45-degree line would be consistent with risk neutrality, and any point above the 45-degree line would be consistent with risk-seeking behavior. So here, for example, for a 10% chance of $10, the median willingness to pay is around 15% or $1.50. So for an expected value of $1, the median subject is willing to pay $1.50 for this gamble. Okay, and what I want to draw your attention to here is this often repeated pattern of people willing to take on risks even beyond the expected value when their odds are unfavorable. And as the odds become favorable, they become less willing to take on risks. And this is the standard explanation for why people buy lottery tickets when the odds are bad and purchase insurance when the odds are good. Okay. So that's what I mean with the local nature of, or the changing nature of risk attitudes. Now, in terms of preference reversals, here's a canonical example. So what I have here are two lotteries. The first one gives you a 30% chance of $10, otherwise nothing. That's the safe lottery. And the lottery on the right, or the risky lottery, gives you a 20% chance of $15. So these lotteries are constructed so that they have exactly the same expected value. And you can see the safe lottery has a higher chance of a lower outcome, while the risky lottery has a lower chance of a higher outcome. That's why I'm saying one's safe and one's risky. You can theoretically show that this is, in fact, the traditional way in which we think about safe versus risk. But just heuristically speaking, you can think of the lottery at the left as being the safe lottery and the lottery on the right as being the risky lottery. So what do people normally observe? So if we ask people in the lab and even in the field whether they prefer the safe lottery or the risk lottery, and we show them side to side, people often express a preference for the safe lottery. Okay. Now, something odd happens if we instead ask people to price each of these lotteries in isolation, where we actually observe people's willingness to pay for the safe lottery to be lower than the willingness to pay for the risky lottery. And going back to kind of the foundational literature, this is the literature and preference reversals from Slovak and Liechtenstein. The basic explanation here is that when you're comparing them, you tend to be focusing on the probabilities. So you pick the safe lottery because it has a higher chance than the riskier lottery. But when you're pricing them, you tend to focus more on the outcomes. So you assign a higher valuation to the risky lottery because it gives you a higher outcome. So that is kind of the psychological explanation for this. And this is a pattern that's often been repeated. So now I've established two things. One is the local or changing nature of risk attitudes. And with this, I was trying to showcase what the standard pattern of preference reversals looks like, but let me put it in economic words, essentially what you're seeing here is that when people compare, they're often more risk averse than when they price. That's the general pattern of the general finding from this preference reversal literature. So when you ask people to price lotteries, they tend to be more risk seeking than when you ask them to do direct comparisons between them. Okay. So as I said before, we care about these things because these are essentially the things that the models tend to want to accommodate. And surprisingly, even though most models kind of have a relationship between preference reversals and the local or changing risk attitudes, very few empirical work actually looks at these things combined. So one way to think about a research question broadly is how are preference reversals affected by the likelihood of a good outcome? That's one way to think about a research question, which is consistent with this idea of the changing nature of risk attitudes and preference reversals. We're connecting the idea of preference reversals changing with the likelihood of a good outcome, essentially. Okay. So without further ado, let me jump directly into the type of tasks that our subjects saw. So we had two types of tasks. The first type of task was a pricing task. So subjects had to express their willingness to pay for a binary gamble. In this case, it was always 0 or a positive price. For most of our subjects, the outcome was $150, so we scaled the incentive significantly. And we essentially asked them for each of these 50-50 gambles, whether they wanted to keep the gamble or exchange it for an amount. And this is, you could think of this as one way of implementing the BDM mechanism in a more transparent way to subjects, right? For each of these binary choices, they just choose whether they want the lottery or the sure amount. And the idea is at the point at which they switch, somewhere between there lies their true valuation for the lottery. Okay, and because it's a BDM mechanism, they have incentives to truthfully revelate what their preferred, either the sure amount of money or the lottery is, their truthful preferences. Okay, so that's one type of task. So here we're fixing the lottery and asking what's the sure amount that they want for the lottery. The second type of task, or what I'm calling a comparing task, instead we had a sure amount of money, and we instead asked the subjects what is their preferred chance of winning $150. So what we're doing here, one way to think about the type of elicitation that we're doing is we're essentially eliciting the risk premia. Let me just remind you, the risk premia is just a measure of distance between the expected value and a subject's willingness to pay for that lottery. So that's the traditional way that we think about risk aversion. And what's nice about this is it's completely non-parametric. So if somebody's willing to pay more for a lottery, then they're more risk-seeking than another person. And you don't need a model. You don't need to take a stand on what the correct shape of preferences is. This is just a non-parametric way of capturing risk aversion. So what we're doing here is for the pricing task, we are fixing the lottery or the expected value and measuring the subjective value for that lottery. That's the way in which we're measuring the risk premia for the pricing task. And for the comparison tasks, we're instead fixing the subjective value of the lottery and instead measuring what's the lottery that would make them indifferent. So these are two equivalent ways of measuring the risk premium. Okay. So one way in which we deviate from the older literature, so we're not the first to look at these differences between pricing and comparison tasks. In fact, for the pricing task, the first picture I showed you, which is from Kahneman and Tversky 1992, essentially has a subset of the same, ours is a subset of the values that they used in their experiment for the chances. But one thing that I kind of already highlighted that we're doing differently is we're scaling up the incentives significantly. But our main contribution is looking at a broader range of comparison tasks. So for the comparison tasks, because we're using a broader range, we're able to observe something that the previous literature missed, which is what I'm terming the certainty effect for preference reversals. Again, going back to the way in which I framed our research question, where we're trying to understand is how do these preference reversals interact with the likelihood of a good outcome? Because people didn't get as near to certainty and as far away from certainty, they missed something. And that's what I'm going to show you in a couple of slides. That's our big result. So this is how we're deviating from the previous literature. Another thing that we're doing, and this is why I'm presenting in this session, is our main sample is agriculture producers. And as you've heard from previous presenters, agriculture producers are notoriously hard to recruit. I do have a fix for this, which is just ask a lot of people to participate in your experiments and pay them a lot of money. So we're actually using the estimates from Laura's, Collins, and Kent's work, and their how to recruit farmers. Basically, their numbers are spot on. Like, just use your table, pay them a lot of money, and they'll show up. So that's kind of a small commercial for Didia's presentation, where, you know, one of the reasons you might want to use students as stand-ins is students are much, much cheaper than farmers. So, but anyway, the main reason that we were recruiting farmers is we were kind of concerned that perhaps this odd pattern of behavior of preference reversals that's been observed with students might not replicate with a more experienced population. So we're trying to see whether throwing a lot of money at this behavioral paradigm and using a subject pool of experienced producers, and I'm calling them experienced producers because these are producers in the US with a gross farm income of $250,000 a year. And I think the median age of our sample was 60 years. So they're really seasoned and good at managing risks, at least in the field. Okay, so without further ado, let me jump straight into our results. So here I'm showing you essentially a replication of the prior literature. So this is kind of redoing the first graph that I showed you from Kahneman and Smirsky's 1992 paper. So again, on the x-axis, I have the chance that you'll get $150. And on the y-axis, I have the median subject's willingness to pay for that lottery in the pricing task, divided by the size of the highest outcome. So once again, if we fixate at the 50% chance of $150, you can see subjects were roughly willing to pay around 45% of $150, which is 45 plus 27.5, which should be, I shouldn't do this math in real time, but I think it's 72.5, $72.50 for a expected value of $75. So slightly risk averse. Okay. But you're seeing the same pattern of people being willing to take on more risks when their odds were bad and less willing to take on risks when their odds were good. Okay. Now, one thing that I will call attention to is if you look at this 10% chance, it's proportionally the same as when the payments were $10, but in dollar values, it's significantly higher. So here, people are willing to pay for a 10% chance of $150 or $15. They're willing to pay, I would say, around 20%, which is $30. So $15 over the expected value. Well, when I showed you this before, it was $1 over the expected value, essentially. So proportionally, we're getting the same results. But if you're measuring risk aversion in dollars, which you should, because if you are, I don't know, selling insurance, this matters more. We're seeing a scaling up of the effects. So proportionally, we're getting the same effects, but in dollar values, we're getting much, much larger effects. And these are significant effects. Okay. So that's for the pricing task. this is what we observe. So now let me show you what happens with the comparisons. So again, we're replicating this pattern of just risk seeking for low odds and risk aversion for higher odds. But for the comparisons, something that you should have already suspected from my discussion of the preference reversals happens, which is people become much more risk averse, right? This is why the blue line moves down. So now what you observe is that people are not willing to pay a lot of money to take on risks, essentially. And this was kind of predicted by the preference reversal literature. Again, one thing that distinguishes from that prior literature is that these effect sizes are humongous, right? So we're talking about people willing. So this is within subject assigned. So all our subjects were exposed to the pricing and to the comparison frame. So essentially, we're removing around $50 of expected value if we were to implement both of these choices. So these are sizable changes. But the thing that struck us as being quite odd and that none of the literature had essentially detected before was this idea, or sorry, this new pattern of reversals. So as I told you from the beginning, the standard pattern is that comparisons make you more risk averse. And what you're seeing here is that near certainty, comparisons actually make you more risk seeking. This is contrary to all of the models in this literature. So essentially, there does not exist a model in this literature that can explain these type of results. Okay. So what we do in the paper, and I'm not going to have a lot of time to do it here, is we combine two ideas. The first is from Kasagi and Raven. This is stochastic reference dependence with an exogenous reference, and impulse response compatibility theory by Slovik, Griffin, and Spersky into something that kind of gives us an explanation for why we're observing these type of results. And rather than inventing a new behavioral bias, we're essentially combining two known behavioral biases in a model which makes them formal, and that allows us to explain this. So this was a mouthful for the model. So let me try and give you the intuition of what's going on here. So if you go back to the choice lists, here I have the pricing task, and here I have the comparison task. So what stochastic reference dependence does is it captures the idea of an endowment effect for risk. What does this mean? It means that when you're in the pricing context, if you assume that the fixed alternative is your endowment and that there is an endowment effect, what you're going to observe is people overwhelmingly preferring the lottery compared to the sure amount because the lottery is their endowment. And for the comparison context, you're overwhelmingly going to see people preferring the sure amount over the lottery because they perceive the sure amount as being their endowment. Okay, so this has to do with whatever alternative in the choice lists is fixed. Okay, now another way of thinking about this, and this is essentially the way that Slovik and Liechtenstein think about this, is rather than fixating on whatever alternative is the same, let's fixate on what's changing. So what's changing in the pricing task are the amounts, and what's changing in the comparison tasks are the probabilities. So their model would say you're going to be more sensitive to changes in the outcomes in the pricing context than you are in the comparison context. So what we do is we essentially combine these two effects using our models, using our model, where essentially we have these like effects from the left-hand side column that's fixed across the two paradigms, and these effects from the right-hand side column that is the changing alternative in both of these price lists. So by doing that, we're able to accommodate this type of result. And again, we're not reinventing anything. This is just the endowment effect plus context-dependent sensitivity, depending to what attribute is changing the most, which is the standard way that psychologists think about these type of effects. Okay, so, and sorry if I'm being extremely hand wavy, but the model is very complicated and I didn't want to get too much into the weeds. But the paper has a more detailed discussion of these things. Sorry. And just to show you what we can do with the model, sorry, how much time do I have left?
Couple more minutes.
Okay, yeah. So just to show you what the model can do, or let me skip over this. I'm not going to have time. Let me just conclude and leave time for questions instead. So as I said from the onset, we evaluate insights from economists and psychologists for preference reversals. We find a new type of preference reversal that the old theories can't explain. We provide a model that combines insights from both of these literatures. This idea of endowment effects and context-dependent sensitivity, kind of merge them into a new model that can actually explain the types of behavior that we're observing. But the thing that I didn't have time to go over necessarily was that we're also, let me actually go back and just talk about this briefly. So one thing that we can generate with our model is we can generate this pattern of willingness to take on risks when the odds are bad and risk aversion when the odds are good. But the standard explanation for prospect theory is that the reason that we observe this is because people overweigh their odds. So what's happening here is that when your odds are bad, you overweigh your odds of that good outcome. And when your odds are relatively good, you overweigh the odds of the bad outcome. So in both cases, it's overweighing of odds, of small odds, essentially.
I'm sorry
Our
to
model-
interrupt, Paul. You just
Yes.
have 1 more minute to finish.
That's fine. That's fine. I'll be finished. Don't worry. So our model doesn't resort to people having to distort their chances. Rather, what's generating this behavior is the fact that people anticipate being surprised, and they anticipate that they're gonna derive additional utility from that surprise. So what happens here is if you win the lottery ticket, you're going to be happier than if you had a high chance of getting $1 million. If you had low chances, you're going to be happier when you get those $1 million. And if you get into a car accident when there was a very low probability, you're going to be sadder of losing those $1 million because you didn't think that it was likely to happen. So we're able to generate the same behavior without resorting to people not understanding probabilities. Okay, so just to conclude, this is how our model can provide insights for old anomalies. And one thing that I didn't present here is we also provide evidence beyond what I did here, where we show that our model is actually good at predicting behavior in other contexts. Okay, and I also have future work trying to see whether we can use, our model allows us to identify kind of a stable trait of risk preferences and a changing trait of risk preferences. So future work will examine whether we can use this stable trait to predict crop insurance decisions. And that's all I got. Oh, and I need to acknowledge the USDA for giving us a lot of money.
Awesome. Thanks, Feldman. So I think in the interest of time, I'm going to jump right into sort of a bit of a discussant overview time, and then we can have questions and comments at the very end in whatever time is left. Does that work for you, Paul?
Yeah, perfect.
All right. Do you want to stop sharing your screen? I mean, not that I have slides, but. Awesome. Great work. Well, thank you so much to all of the presenters. I really enjoyed that session. And so Pallavi asked me to come today with a few comments and sort of discussant role. So my name is Laura Paul. I'm at the USDA ERS with the Rural Economy Branch. But until recently, I was with the Center for Behavioral and Experimental Agro-Environmental Economic Research, and at the University of Delaware. So a quick disclaimer, the findings and conclusions in this session and my comments have not been formally disseminated by the U.S. Department of Agriculture and should not be construed to represent any agency, determination, or policy. Okay, So with that out of the way, this session featured research using large sample field experiments with agricultural producers and students to inform agricultural policies and programs. And so many thanks to Dr. Pallavi Shukla for organizing. Overall, the session had these two papers that used lab in the field experiments to understand sort of the intertemporal decision-making and decision-making under uncertainty by agricultural producers. And both of them included contrast between their behavior and the behavior of a sample of university students. The other paper used a field experiment to contribute to the body of experimental evidence on the effects of behavioral nudges, such as anchoring and in the context of agricultural producers. So one thing that I think is quite remarkable about the research in this session is how it highlights the opportunities for partnerships between academia and government and nonprofit groups sort of working to expand the evidence base for agricultural policy through the use of experimental methods and behavioral insights. So to give some specifics, of things that I thought were interesting, my key takeaways. So from Dr. Dia Ganguly, we heard about the effects of time horizons, delays, and the sort of incentive size on preferences of both agricultural producers and university students. And the key takeaway here that was really interesting to hear was that students demonstrated reasonably similar time preferences to producers in specific cases where the incentives were large enough and front-end delays and time horizons are short. So then we heard from Dr. Kent Messer on the interaction of behavioral interventions in an experiment that included an auction. And there were a couple of really interesting things in this project, specifically thinking about sort of the importance of both considering and then testing the stacking of different behavioral nudges. And then another takeaway was just that using some of these behavioral interventions could lead to a more efficient use of, say, a fixed budget for a program. And then finally, thanks, Feldman, Dr. Paul Feldman, for your presentation, looking at findings from your lab in the field and lab experiment to explore sort of changing risk attitudes and preference reversals. And really, I felt like your work gave some good motivation and sort of made it interesting to think about why measuring risk preferences and sort of how we're thinking about that is important for policy. So overall, this session and these papers make important contributions to ongoing efforts to develop evidence for agricultural policy. So the Evidence Act of 2018 does requires that federal agencies, including USDA, develop sort of increasing evidence base to inform policies that are developed and improved. And so, I know that everyone is interested in this room in using the experimental approach to create that evidence, and it allows researchers like the ones we listened to today to sort of test decision-making behaviors in real-world settings. However, for statistical validity, these experiments must recruit sufficient sample sizes. So we heard about that in today's presentation, some of the challenges and sort of strategies for increasing sample size. I think Feldman referenced it, but we are often seeing response rates of less than 10%, and that can be quite difficult when the overall population is not too large. So, an interesting sort of potential addition to the farmer sample would be using a student sample, which can sort of reduce costs in financial, time, and sort of effort senses for conducting the experiment. So sort of to wrap up, I want to say today's presentations were awesome. Thank you so much for having me here. And they give me quite a bit of optimism about the sort of potential of partnerships and experimental methods to sort of create insights that can inform policy. So my question sort of to leave for all the speakers and maybe anybody for discussion in the room is sort of, what is the future of evidence-based agricultural policies? Will student samples become more widespread? Will behavioral nudges and stacking these nudges be increasingly used? Sort of where do we go from here at this point? Thank you. With 2 minutes left. And Feldman, I do say that Pallavi had a question for you in the chat, which does fit into my question as well.
So I'll quickly answer that question and kind of talk about the policy implications, and then I'll leave some chance to Dia to answer in the last minute. So in terms of one policy implication of this work is there's been a lot of recent attention paid to whether we can use lottery tickets to incentivize behavior, for example, the COVID lotteries. And the main result from all of that literature is that it doesn't seem that lotteries work, right? If you believe this idea that people distort probabilities, then lotteries should work, but they don't. So that's our research kind of gives you a reason why we haven't seen those policy incentives work in practice, even though in theory they should be very, very strong.
Cool.
Happy to take other questions. If any. Yes. Dr. Paul Feldman. Yeah.
But obviously they're
Okay, so Paul, the question is that which method do you think should be implemented, and do we continue as we are going, or do you think there's another better way of going about eliciting risk?
So I'm not sure we know yet. The work that I did is fairly restricted to non-convex methods. So I'm not sure how I would extrapolate them to convex methods. That's the first part of the answer. The second part of the answer is I kind of highlighted that the model lets you identify kind of a stable trait of preferences and the changing trait. So the only way you can do that is by having two choice paradigms. It's kind of like, how do you identify loss aversion? Well, you need a gain frame and a loss frame. If you don't have both frames, then we can't say what loss aversion would be. So the big answer in a nutshell is we need to combine the methods and use kind of a structural approach to tease out what risk preferences are.
Sense. Any other questions? All right, then I think we can wrap this session up. Thank you so much, everyone, for attending, and we look forward. If you come up with any other questions later, please do feel free to email us. Yep. Thank you.